All right, so I apologize if this video seems a little rushed. I'm doing it in the last 8 minutes of lunch right before your class. So this is the Chapter 5 warm-up, so if you are on Chapter 4, you shouldn't be watching this video. For Chapter 5 people, the first question asks, tell whether x and y are proportional. And so we talked about during our last class that a proportional relationship exists when two ratios, they either simplify to the same fraction or they divide into the same decimal, but they all have to be equal to one another essentially. So for this ratio table here, we would want to do, the easiest thing to do is to turn them all into their simplest form. 2 over 16 would turn into 1/8. 3 over 24 would also turn into 1/8. 4 over 32, same thing. And then 5 over 45, that's where it changes up. So that's where that fraction is going to simplify, or that ratio will simplify into 1/9. And so because there's one that is different from the others, they're not all equal, you would put that they are not proportional. Even if the other three are proportional, because that one is not proportional, you put no, they would not have a proportional relationship. In the next question, you're being asked to solve for x, and you have 4 different proportional relationships. Now, there's a few different ways of solving for x. You could either do it mentally, which some of these you can do, or you can use the cross products. Now, for the first one, I would recommend to do it mentally, because if we look at the denominators, the bottom numbers, then 2 to get to 12, that's a pretty straightforward operation. You're going to multiply by 6. So that means that the top number, this 3, you're also going to multiply it by 6 to determine what the new value of x is going to be. And 3 times 6 equals 18. The next one you might be able to do mentally if you recognize that 2.5 multiplied by 4 will get you to 10. If you don't recognize that right away, you can solve it out by doing the cross products and solving for x. So 2.5 times x would be 2.5x. Set that equal to 10 times 4, which is 40. And then to solve for x, you're going to have to get rid of that 2.5. It's being multiplied by x, so you're going to do the opposite, which is to divide by 2.5. And you're not going to do that just to the left side, you're also going to do it to the right side. That's going to leave you with x. And then you have to determine what is 40 divided by 2.5. Will you do 40 on the inside, 2.5 on the outside? Going to have to change that decimal, move it over one time to turn that into a 25, which means you're going to take the imaginary decimal at the end of 40 and also move it over one time and change it into 400. And then now the question is, how many times does 25 go into 400? You would do 25 times 2 times 3 times 4, eventually realize that 25 times 8 goes into 400 evenly. It's kind of like having 8 quarters. 25 times 16. If you have 16 quarters, that makes $4. So x is going to equal 16. And then you would do that with the rest of the numbers. So you would do here 30 times x. That's going to be 30x is equal to 15 times 14. Divide both sides by 30. And notice how I didn't solve out what 15 times 14 is, because I'm going to actually simplify before I do my division. So I know over here I would get the x by itself, but on the other side, I can simplify the 15 and the 30. 15 and 30 simplify to 1 over 2, and then now it's just 1 times 14 divided by 2. 1 times 14 is 14, divided by 2 means that x is equal to 7. Which you also could have solved mentally on this one, because 15 to get to 30, that would be times 2, and then you're going to take a number times 2 will get to 14. 7 times 2 gets you to 14. Now this last one, I wanted you to recognize that we have the same number over each other. 3 divided by 3, that's going to equal 1. So that means that you want to put 8 over some number that when you divide them by each other will also equal 1. Well, any number over itself is going to equal 1. So if you set x equal to 8, 8 over 8 is also equal to 1. So this one, you didn't have to do any sort of mental math. You didn't have to do any calculations if you recognize that you would have to have the same number over itself for both sides to equal 1. All right, you buy a 1:4 scale model of the Statue of Liberty during a trip to New York City. The height of the model is 9.3 centimeters. Find the actual height x of the Statue of Liberty. So the scale is, what that tells us, that 1:4, is that for every 1 centimeter in the scale, there's 4 centimeters in real life. Now, I changed the numbers around, so this isn't very realistic, but we still use the same technique. 1 centimeter in the scale equals 4 centimeters in real life. And so then we're told that the height of the model is 9.3 centimeters. So I'm going to change this word scale here to model. So if the model is 9.3 centimeters, then we need to figure out how much is the real life Statue of Liberty, which you would do by solving for x. In this case, it's 1 times x, means that the x is already going to be by itself. So you just need to multiply these two values to figure out what 9.3 times 4 would get you, which is going to end up being 37.2 meters. On solving the proportion on the back page, we've got x plus 2 is to 6 as 12 is to 3. And you're solving for x, so you're going to be needing to utilize the same technique that you do with all cross product problems. You're going to multiply 6 times 12, which is going to be 72. And then you're also going to multiply the other cross products, which is going to be 3 times x plus 2. Now, here you have to recall back into expressions when we used to do the distributive property. So we're going to do 72 is equal to 3 times x, and then 3 times 2, that's going to be 3x plus 6. And then now it's back to chapter 4. We are solving for x in a two-step equation. Then to get the x by itself, we're going to have to subtract 6 from both sides, which leaves us with 66 is equal to 3x. Divide both sides by 3, and you get 66 divided by 3 goes in 2 times, another 2 times, and so x is equal to 22. So that one had a lot of steps with things that we've already gone over in class several times, so you can see how all the chapters build up with one another. The very last problem, use a graph to find the unit rate for renting a kayak. Now this one's about being able to read the graph properly. You have to recognize what these coordinates mean. Just remember that the first coordinate, this first little number, is going to be the x value. So the number of hours that we rented the kayak. And then the second number, the 50, is going to be the cost, the y value. So what this is telling me is that it costs $50 to rent the kayak for 5 hours. And the unit rate of that, or figuring out how much each hour costs, would be just dividing the numbers, and it would be $10 an hour. And that's the same kind of technique that you're going to use for this last one. If you didn't solve that one, I want you to go ahead and try it now.